talk about extrema, and this has to do with the lowest and the highest regions, highest y values on a graph. So you can either have relative extrema or absolute extrema. Relative is like within a certain region, and then absolute is as the function as a whole. And you can either have relative or absolute minimums or maximums, and the minimums are the lowest y values on the graph, and the maximums are your greatest y values. So let's look at some examples. We have a graph right here, basic parabola, and we can see that it has an absolute minimum at x equals 0 right here. Because on the function as a whole, that is the lowest point on the graph. And absolute minimums or maximums are always relative, but it's not relative or isn't always absolute. So like here's an example where absolute and relative are the same. Because within the region, that is the lowest point, so it's the relative minimum, but it's also the absolute minimum. But if asked, you'll just put absolute minimum. Okay, and this one has no maximum, because you can see it infinitely increases in each direction, so there's no maximum there. And here we have absolute and relative minimums and maximums. We have an absolute minimum at y equals -1 right here, because that's the lowest point on the graph. And this is on the interval -3, 3. Hold on. Open brackets, because we're not including these points right now. So on this interval, we have absolute maximums at y equals +3. See, these are the highest points on the graph. They're both absolutes. They're both the same value. And we have an absolute minimum at y equals -1. On this interval, we see that we have absolute maximum at y equals 8. We have an absolute minimum at y equals -8. And then we have relative minimums at, relative minimum at x equals -4. And we have a relative maximum at y equals 4. So what you want to do is you want to mark wherever the direction changes are and your endpoints. So here's the direction change because we're increasing, and then right here we're decreasing. Here's the direction change because we're decreasing and now we're increasing. And here's another direction change right here because we were increasing, now we're decreasing, and here's an endpoint, so you want to mark that one too. So you look to see where the direction changes are, and that's how you mark your relatives. So within this range, this is a maximum. Within this range, from right here to right here, this is a minimum. From here to here, this is a maximum, and from here to here, this is a minimum. So that's how you find your relative extrema. And your absolute extrema, you want to remember, is the function as a whole. So out of all the relatives, which one has the lowest value, y value, and which one has the greatest y value?
Alright, now sometimes you might be asked to find the extrema, but you're not given a graph to look at. So first we're going to try one on a closed interval. So say you're given the function g of x equals 2x squared minus 8x. And we want to know the extrema on the interval 0, 6. Alright, now what you want to do first is you want to differentiate the given function. So when we differentiate this, we get g prime of x equals, we find using the power rule that it equals 4x minus 8. Alright, now whenever you have your differentiated equation, you want to set it equal to 0. So let's set 4x minus 8 equal to 0. And then you isolate the x, and you get x equals 2. So this is what we call a critical number. All right, and this problem is asking for the absolute extrema of the function. So what we want to do is we want to plug in the endpoints and the critical number that we just found. And remember, this is only to find the absolute. You do something different when you're trying to find relative. Okay, so an absolute, what you want to do is you plug in the endpoints into the original equation, the critical point. So let's start with g of 0 equals 2 times 0 squared minus 8 times 0. So this point would be 0, 0. All right, now let's find what g of 2 would be. So if we plug in 2, we get 2 times 2 squared minus 8 times 2. All right, now this becomes 8 minus 16, which equals negative 8. So this point is 2, negative 8. All right, now let's plug in this last endpoint right here. Let's plug in 6, and when we plug in g of 6 equals 2 times 6 squared, 2 times 6 squared minus 8. Ooh, running out of room here. All right, well, let me erase this so I can have more room. So g of 6 equals 2 times 6 squared minus 8 times 6. All right, and this becomes 36 times 2 minus 48. 36 times 2 is 72. And then we subtract 48, and we get 24. So this is 6, 24. All right, so now let's look at these coordinates. We have 0, 0, 2, negative 8, and 6, 24. So let's look for our highest and our absolute minimums and our absolute maximums. And to do this, we look at the y values. So we look for the lowest y value first, and we see that negative 8 is our lowest y value out of negative 8, 0, and 24. So this right here is our absolute minimum. Now let's look at the remaining coordinates at the y value to find the highest one. And we have 0 and 24. Well, 24 is our highest y value, so we know that this is our absolute maximum.